codec file. I pretend to be a Media Player 9 installer or something. Searches all your documents, encrypts them all, and says, send $10. Here, I'll show you the message. It sets the wallpaper on the desktop of the machine to this picture. And I wouldn't translate it, but basically the author of this wants 350 rubles, which is about $10, to send to the decryptor. So anyway, I analyzed it in about half an hour and saved everybody $10. So so this is the crypto routine I used, and it turns out it's actually after I analyzed it, I did some web searches and I found the blog post of the guy who originally wrote the crypto routines, going about, here's this great crypto routine I just thought of. It does this, and basically you take the password, take the first byte of it and move it to the end. And then you take the second byte and move it to the end. And then you take the third byte and move it to the end. And then you take the fourth byte and move it to the end. And this is an order-preserving operation. Then it uses the password that is shuffling, runs it with CRC32 and gets 4 bytes of output, and that's used as the key stream. And now it sort of stands to reason that if you do this sort of shuffle with like a deck of cards or anything, you're eventually going to shuffle it back into the original order. And for the case of a password of about 38 characters, this happens after about 1,110 shuffles. So the key stream is only 4,440 bytes long. And making the password longer doesn't actually help. It's not a linear relationship. So a password of 50 characters actually has a shorter cycle. And it does start getting bigger, but it's some weird nonlinear thing. It bounces up and down. The only thing I was able to find about it was I don't know if everybody here is familiar with the online encyclopedia of integer sequences. It's like great. You type in a sequence of numbers, and I'll tell you the formula that produces it. Anyway, so for this particular one, it was basically that sequence times n-1. So Vundu is a malware, family of malware that's been around for like a year or two, usually associated with fake AV software. It gets in your system and basically says, "Oh my God, you've got a virus on your system," and go to this website run by a bunch of Russian mobsters to download a fake AV program that'll keep protected. So earlier this year, it started dropping a program that would go and encrypt all your document files, and then it would pop up a little message box in from the system tray saying that, oh my God, Windows has just detected file corruption, and click here to fix it. And it was like it all looked like an official Windows system dialog box. So anyway, I didn't actually have a copy at the time when I did this analysis. I didn't actually have a copy of the malware that was doing the encryption, but I did get a copy of the decryptor, which is all I needed to know. So I got a couple of samples from some of the victims, and basically confirmed my suspicion that it was just doing a repeated XOR type thing. And the way that the FileFix Pro knows that a file has been encrypted or not is the bytes of the key have a mathematical relationship to each other, and so you can do this test on it using this key for an example. You basically take the second byte. I'm going to call this one the first byte, and this one the third. This one the 0th byte, and this one the 4th byte, third byte, just to confuse everybody. Sorry, it makes sense if you're used to reading these in little endian format. So you basically take that value, divide it in half, or bit shift it down by 1. So it's 66. And if you take, then if you XOR that value with that value, and it comes out to that value, then the key's good. Anyway, there's a very small key space. You can generate the entire key space with this small Perl program here. And anyway, so out of possibility of 32 bits, it only uses 2 to the 8th minus 1 of them. So statistically, about 1 time out of 16 million, you'll mistakenly find assuming a perfectly random distribution, which is not necessarily true for a lot of document files, you'll just randomly corrupt a file when you think it's decrypted, and it isn't. So this is the original assembly code. If anyone actually wants me to go through this up on stage, like speak now, and anyone? Okay. But basically it's just doing the bit shift and XOR and so forth. So all the spam bots have been encrypting their templates lately. Symbot, for example, it generates this big string here off of like the system volume ID and the CPU ID and a bunch of the machine name and so forth. Anyway, it's basically just a big random number. I use that to apparently log in. I'm guessing L.php is for the login of this thing, and the botnet, the command and control server, just sets a regular cookie that it uses for all the further communication. It's just like just like any other PHP-based website. So I'm not entirely certain if D means get data, but generally it goes and goes and hang on a second. This string of stuff here actually has a meaning that's completely irrelevant. But when it does the request, it gets back a GIF file or something that looks like a GIF file, but it's not really. It's actually corrupted. The actual bits of GIF stop there, and then everything else is the actual spam template. So if you pull it, if you look at some button in IDA, you get this, and you eventually find there's this. This is how a lot of the crypto code ends up looking. Is you basically just have a loop, and then you've got like a simple operator in the middle for doing the decryption. So I'll zoom in on that. In this particular case, it uses subtract instead of XOR, and this is just in context. It checks to make sure that the input's more than like 15 bytes and stuff. So when you decrypt this, the result is this. So, ta-da! Anyway, and it's basically a spam template saying search through these bunch of files for anything that looks like an email address and send this particular message to these 5,000 email addresses or whatever. So bad programming. So this is sort of one of the commonness here is that a lot of malware is very sophisticatedly written, and the people who are doing it know what they're doing, and that's not really true. Actually, most malware software is absolutely terrible code. It's absolutely full of bugs. It's a miracle it works at all. If you actually get a hold of some of the source code for some of them, it's rather obvious that whoever put them together doesn't know how to program. They just sort of cut and paste stuff from a bunch of other places. So this is an example of that, not an example of that. But when I was skimming through this code real fast, there's a FTP server in this particular bot, and I noticed this